So up to this point, when substituting in order to solve an equation in quadratic form, things were being squared, so it was almost in quadratic form to begin with. But if you'll notice with this equation, we have x and the square root of x. Nothing's being squared. So we're going to do a substitution, but it's going to have to be in the opposite direction of what we've been doing up to this point. Instead of substituting something that's being squared, or in a quartic, something that's being to the fourth power, u will equal the square root of x. And then when we put this in terms of u, it will be a quadratic. With u equals the square root of x, that means u squared equals x. So when we substitute, we have u squared minus 7 times u, the square root of x, plus 12 equals 0. And now we can solve it in quadratic form. So as always, we look to see, will it factor first? Are there any numbers that multiply to 12 that add to negative 7? And there are negative 3 and negative 4. Negative 3 times negative 4 is 12. And negative 3 plus negative 4 is negative 7. So this will factor to u minus 3 times u minus 4 equals 0. So u equals 3 or u equals 4. And now we'll back substitute to solve for x. The square root of x equals 3 or the square root of x equals 4. Squaring both sides, we get x equals 9 or x equals 16. 4 squared, which is 16. So now we will substitute into the original equation to check our solution. Since we are squaring things, we need to check for extraneous solutions as well. So 9 minus 7 times the square root of 9 plus 12, does that equal 0? So 9 minus 21, because the square root of 9 is 3, 7 times 3 is 21. 9 minus 21 does equal negative 12, plus 12 does equal 0. So now we'll check x equals 16 in the same way. 16 minus 7 times the square root of 16, or plus 12, does that equal 0? 16 minus 7 times 4 is going to be 28. Plus 12, again, does that equal 0? 16 minus 28 is negative 12, plus 12 does equal 0, so that solution checks as well. So we know that x equals 9 or x equals 16. And again, we did this by substituting u equals the square root of x so that we could put it in quadratic form, solve for u, and then back substitute to solve for x, and then checked our solutions by plugging them into the original equation. And the key here is the first term is to the first degree. The second term is the square root. That's when we're going to recognize that we can substitute for the square root in order to form a quadratic.